But it's easy to mix up. Do I add? Do I multiply? What's the rule again? Okay. Yeah, here I need a common denominator when I add. You know, I think this thing goes all screwy right when I try to record. Okay. So that goes in there 3 times. That goes in there twice. That's 5/6. Okay. When you're adding or subtracting, you need a common denominator. Here we don't. You just multiply straight across. Okay. So I'm not going to entirely follow this the way they're asking me to. Let's just ask this question. Do we believe that? See a couple nods. Someone said a no. Well, if we had this and the question was simplify it, i.e. make that entire radical a mixed radical as simplified as possible, what would we do? We would go like this, right? Because I want to find perfect squares in here. I know the square root of 4 is 2 times root 5. That's the same as this. You can check it on your calculator. That's what they're asking us to do here to see if it's the same thing. I hope by now we know that is the same thing, okay? But hey, if you're in doubt, check it. Maybe you made a mistake. Okay? Because some of us still want to do this for some reason. We want to carry this root sign down here. You know the square root of 4 is 2, but we still want to write root 2. Well, if you put that in your calculator, you will see it's not the same decimal as that. Okay? So, what am I saying here? Can I multiply root 4 and root 5 and get root 20? Let's just go backwards. You already know you can, because you can do that. So can I do this? Isn't that the same thing? You can multiply these two radicals and get this. So do you think this is going to work? If I put this on a calculator, you will see that it will. Okay? I can do that. This one maybe looks a little funkier. So let's try that. Let's see if that works. Okay, we should all know how to put this in our calculator. I'm teaching the grade 10s how to do this right now. 2 root 5 times, okay, negative 4 times root 3. I didn't have to split those up, but maybe that's how we see it. Okay, that's minus 30.8. Let's see what negative 8 times root 15 is. Ah, it's the same thing. Okay? I know this is equal to this one. So, how do you do that without a calculator? How do you do that manually? Do you see what they did? See the whole number here too? You see this integer, negative 4? How do you think they got negative 8? They multiplied them. Okay? And just like this one, 2 times 3 is 6, all square root. Root 5 times root 3 is 5 times 3, 15? Okay. Do you think you could come up with a rule on how you multiply radicals? Mixed radicals? How did we get from here to there? Write a rule. What did we do? We multiplied the numbers together, okay? And then we multiplied the radicals together. So I'll just speak a little bit more about this guy. If I go A, B, C, D, is that the same thing as A times C times B times D? Does it matter what order we do these in? No. I'm going to get the same answer. So can I write this as 2 times negative 4 times root 5 times root 3? Sure. And if that helps you visualize what you need to do, then you do it. Okay? But if we're good at memorizing rules, that's what we do. Okay? And by the way, it says it right here. Okay? To multiply radicals, but we didn't know this part yet. So let's go back and look at example C. The index must be the same. Are the indexes the same in C? What's the index again? That's that little number up here. This one is a square root. This one's a cubed root. I just finished showing you if the indexes must be the same in order for us to multiply. So do we think this one's going to work? No. Okay, let's prove that. I'm not sure yet. Square root of 2 times the...
Teachers, please excuse this interruption. Would all grade 8 students please go to room 120? That's all grade 8 students to room 120. Thank you.
Anybody here in grade 8? That's 2.24. Okay. Do I need to put cubed root of 8 in my calculator? I hope not. What times what times what is 8? That's right. Put the calculator down, Shoni. 2.24 is not equal to 2. That doesn't work. And this is the biology method you memorize, okay? We see that doesn't work, and I've already told you the reason why, okay? So you can't multiply these if you do not have the same index. If you do have the same index, that's fine. You multiply them together. Do these have the same index? Cubed root, cubed root. Do we think we can multiply these? Yes, we can. How do we do that? You multiply the numbers together. 2 times 3 is 6. And then you multiply these together, just like we always did before. Okay? 4 times 5 is 20. 10 times 7 is 70. That's going to be true. Okay? Do these have the same index? No. Can't do it. All right? Now, note this. Here's Mr. Policeman with his octagon. It says note. It's usually easier to convert first. That's what it says. Okay? Let's keep that in mind. Okay, multiply and simplify if you can. Some of these, know your rules. You can't do it. All right? Can I do this one? Is it the same index? Yes. Can I simplify root 64? Yes. How about these? Can I multiply this one? Do I have the same index? Then I can. They're both square root. Okay, how do I do that? 4 times 3 is 12. And root 5 times root 6 is root 30. Is there a perfect square in 30 I can take out? 4? No. 9? No. 16? No. 25? No. How about 36? Can I take a 36 out of a 30? I think we're done. Yeah. Lewis? I think you're in the wrong class. Okay. This is totally different, right? I don't have numbers here. I have letters. Or is it? Do they have the same index? Yes. That means, can I multiply them? Yes. What's 4 times 3? 12. What's x times y? Dannon? Very good. That's it. You can still do it. Okay? Same rule. Do these have the same index? Yep, both square root. And remember, if you like the 2 there, hey, feel free. Negative 2 times 5, negative 10. 8 times 12 is 96. Can I simplify 96? Is there a perfect square in 96? Okay, and again, I told you this yesterday. Let's try this. Does 2 go in there? 45, 48 times 2 goes in there. Well, you know what? Maybe I know that's 12 times 4. Okay, and that is 3 times 4. Okay, in grade 10, yeah, we would break this down into 2 and 2, but I'm trying to find perfect squares in here. 96 is 4 times 4 times 3 times 2. So I'm sure I can take a 4 out, but is there something bigger I can take out? Yeah. 16 times 6 is 96. Root 16, root 6, and what's the square root of 16? And negative 10 times 4 is negative 40, root 6. There's no more perfect squares than 6. I'm done. You saw these in grade 9, only they didn't have radicals in them. This is called distributive law. Okay? Multiply everything in the brackets by everything out of the bracket. How do I, well, first of all, can I multiply this? Do they all have the same index? Okay. First, what are the rules? Multiply your numbers together. What are the two numbers here? For this mixed radical and that mixed radical. Yeah, what's 1 times 2? Okay, so there's still a number there. Actually, it's not a mixed, it's an entire. So I'll correct myself. 2 times 1 is 2. Root 5 times root 10 is root 50. Okay, minus root 5 times root 5. Someone said 5. Yeah, let's go root 25 first. And yes, that's 5. Distributive law, right? Say 2 root 50. Now, can I simplify root 50? 10 times 5, right, Dan? Ah, that's good, good, very good. 2 root 25 times root 2 minus 5. And this is, I'll skip a step, right? This is 5 times 2. See that, Brianna? Okay, root 25 is 5 times 2, so we get 10 root 2 minus 5. Can I collect a root 2 and a number? No. They're unlike terms, right? I can't collect an x and an x squared. That's fully simplified. I can't do anything with this. I can't collect these. Don't try to. It's not minus 5 root 2. Come on. Here? Okay, root 25 is 5, right? Well, what's the square root of 25? Yeah. Yeah, I know it's confusing, I know. Okay? Square root of 25 is 5. Square root of 25 is 5. How can you also do this? What's root 5 times root 5? I got 2 of them. Right? What's 4 times 4? Don't say 16, say 4 squared. What's root 5 times root 5? Root 5 squared. And remember, if you like exponents, the bottom part is the denominator. The exponent part is the numerator. 2 divided by 2 is 1, and that's just 5. That's another way to think about it. Okay. Everything outside the brackets gets multiplied by everything in the brackets. Okay? I can only multiply them if I have all the same index. Are these all the same index? They're all square roots. Yes? Okay? So I'm just going to do the first one. 2 times 3, 6. Root 5 times root 45. Let's just write it out like that for now. Shelby? Close your mouth. Okay, second one. Negative, put down negative. The numbers first, 8 times 2. 5 times 45. Well, I just wanted to write it as another step. Yeah, like Dannon said, that's 225. Why don't you just put 225? Well, why not? Okay, 8 times 2, 16. This one I can do in my head. What's root 5 times root 5? Let's just write root 25. You know that's 5. Let's just write root 25. Okay, 2 down, 1 to go. This times 2 root 5 is plus 6 root 20 times 5. Oh, that one's a nice one. Okay, so first step, get rid of the brackets, just like you did in grade 9. Now, can I simplify it? 6 times and 45 times 5, Dannon? 225. 16 times, what's root 25? 16 times, well, let's just write that out. What is 16 times 5? Who remembers that from yesterday? Yeah. 80? Yeah. Remember seeing a root 80 in there yesterday? A couple of them? Okay. Okay, let's do another step. 16 times, what's root 25? Two separate numbers, two separate radicals. Not the number and the radical. But if the radical is something nice, we want to get rid of the radical. If it's not something nice, I can't do anything with that, right? Okay, we know where this came from, right? Root 25? That was root 5 times root 5. Okay, root 25.
What I'm saying is just why would you multiply like 16 and 6 and 25 to make 1?
16 and 6? Why wouldn't I multiply these? Because there's a plus sign in between them.
So you can just get rid of something like that?
Well, this is 16. This becomes 5. Okay? What is, let me look at the next one. Plus, what's root 100? 6 times 10. I'm just simplifying it, right? I'm just simplifying it. That's all I did here. I didn't multiply anything. These are already multiplied. 16 times root 25. But if I know what root 25 is, I'm going to make that a nice number. That's a perfect square. Let's get rid of the root, right? If you know what the square root of something is, if it's a perfect square, We're going to get rid of the root sign. 225. Oh, is it? How do we find out if that is a perfect square? Okay, some of us remember that from grade 10 maybe. I don't know how else you would know that. How would you know that, Dana? How did you know 220? Because you guys don't learn the 15 times table. You only go up to 12. So the last perfect square you kind of know is 144. Say it again? No, you did not. Okay. Let's pretend we didn't know that. The square root of 225. Why would I check to see if it's a perfect square? You would probably do something like this. You would go, I'm going to write over here, okay? Root 225. Is there a perfect square I know that goes in there? 25? Okay, how many times does that go in there? That's $2.25 is how many quarters? 9. Okay? And then I would go, oh, look, that's 5, that's 3, and this is 15. Okay? You're going to get to the same place if you don't know the square root of 225. Okay? It just takes you a couple more steps. So that is 6. The square root of 225 is 15. Get rid of the radical. Okay? It's a nice number. It's a perfect square. Minus 16 times 5 is 80, plus 60. And what's 6 times 15? 6 times 10 is 60. 6 times 5 is 30. That's 90, right? 90 minus 80 plus 60 is what? Well, that's a lot nicer than this thing, don't you think? That's simplified quite nicely. Okay? Questions? Okay. Now, one thing I'll point out, it did say if you can simplify a radical first, maybe you'd want to simplify root 45 first and make it a little smaller number. In this case, it worked out to something really nice. But again, just keep that in mind. Sometimes you're going to want to simplify something to make it a smaller number. Okay. It looks big and long and ugly. Just one thing at a time. Forget that's even there. Just do the first part first. Okay? Don't cross that out in your book. Distributive law. Okay? Multiply everything out of the brackets to everything in the brackets. And there's no radical times radical here, so I can do this irregardless, right? Okay? 2 times root 3, 2 root 3. Minus 2 times root 5, 2 root 5. Okay? First one's done. Now look at the second one. Okay? This is minus root 2. Minus root 2 times root 6. Okay, first multiply the numbers together, but what are the numbers? If it helps, put them in there. What's negative 1 times 1? Negative 1. Now multiply the radicals together. Root 2 times root 6 is root 12. Do I need that 1 in there? No. But if it helps, hey, if you like to see it, keep it there. Okay? negative root 2 times positive root 10. Multiply the numbers together, minus 1. Root 2 times root 10 is root 20. Okay? Okay, no more brackets. That's your first step. Now just simplify it. See if we can collect some like radicals, because this one's multiplying, but we're also doing addition in here as well, and subtraction, right? Okay, so once you get to multiplying, and then tomorrow or the next day you get into dividing, well, you're still going to have adding and subtracting in there. Okay, so it's like both. Can I do anything with a root 3? Can I simplify that? No. Root 5, can I do anything? No. Root 12? Yes. So I still have, let's just do another line. Okay, what is a perfect square? How many steps can I skip here now? Do we know what that is fully simplified yet? That's 2 root 3. Everybody see that? Okay, if you don't, well, that's what we want to do. What's the square root of 4? I know what that is. Get rid of the radical. It's a perfect square. Root 12 is 2 root 3. So I see I have a couple of root 3's I can collect. Root 20 is root 4 times root 5. That's 2 root 5. Are there any like radicals I can collect? I already said there was. How many root 3's do I have? You sure I have 2? I have 4? What's 2 take away 2? I have no root 3's. 2x take away 2x is 0x. That means you don't write anything. Okay. Everybody okay with that? Negative 2 root 5, negative 2 root 5's. Let's let root 5's be dollars. You owe $2. You owe another $2. How many dollars do you owe? Okay? So again, this big ugly thing simplifies all the way down to that. Okay? Oh, I better do one with the letters. Same thing, only one set of brackets. Let's get rid of them. How do I do that? Multiply the numbers together. Negative 4 times 1 is minus 4. Root A times root A. How do you want to do this? Root A times A. Are you okay with that? Yeah, that's going to become A, but let's write it like that for now. Everybody okay with that? Yeah. You multiply the radicals together. We just did this, okay? That's like root 4 times root 5 is root 4 times 5. Okay? Negative times the negative is 4 times 9. Root A times root B. Okay, first step, just get rid of the brackets. Negative 4 root A squared is just A. Plus 36. Can I do anything with root AB? Is it like root B squared or something like that? No. That's it. That's all I can do. Okay. Yesterday you saw some shapes. You did perimeter. You know how to calculate the area of a rectangle? What's the formula, Brooke? Formula for area of a rectangle. Can I go width times length? Sure, doesn't matter. Do I know the length? Yes. Usually we take that as the longest side, length. That makes sense in our language. And then I need to multiply that by the width. Is that correct? Or did I miss something? And you know I did, because why would I ask the question, right? What am I missing? Aha. It's this length times the width. It's not half of the length times half of the width. Add a little bit of more length, add a little bit more width, okay? Do we look like we're, well, let me ask you what this is called from grade 10. Is that like multiplying a couple of binomials? You remember this? FOIL, you bet. First, outside, inside, last, okay? What's first? 4 times 7, 28. Outside, 4 times minus root 6 is negative 4 root 6. Inside, root 6 times 7 is 7. Let's put the number out front. Root 6. Last, negative root 6 times root 6, or root 36. Yes, that becomes 6. Again, do you like root 6 squared? Same thing, right? That's going to become 6. I don't know how your brain wants to think of it. All we do is simplify. How many numbers can I collect here? Well, we don't know yet, because maybe this one's going to become a number. Let me just write it out again. Okay, that's 28. Can I simplify root 6? No perfect squares in 6. Do I have some root 6's to collect? How many root 6's do I have? What's 7 take away 4? Right? Let root 6 be an apple. Minus 4 apples, plus 7 apples. It's like I have 3 apples. And this is negative root 6 squared, or negative 6. So now I have a couple numbers to collect. That's 22 plus 3 root 6. That's the area simplified. Okay? Okay, that's where I'll stop for today, guys, okay? One and 3 odds. All of us know what odds mean, right? There's no new students in here. A, C, E, right? Every second letter. 4 to 5 and 6 to 11 odds. And again, quiz tomorrow, right? So if you're done, study.